There's been a significant change in the way boundaries are associated or linked to toolpaths. This change gives great benefits when it comes to editing the parameters of the toolpath. Before we look at the improvements to boundaries and toolpaths, let's just remind ourselves of the way it used to work in PowerMILL 2012 R2. So in this example I have a shallow boundary created with a slope angle of 30 degrees and a tolerance of 0.1 and a thickness of 0. That shallow boundary is being used by this raster toolpath. So there we can see the shallow boundary highlighted or selected on the limit page, and the parameters of our toolpath match our boundary, which is what they should do if we want to machine in the correct amount of material and in the correct place. So we have a tolerance of 0.1 and a thickness of 0. Now if I go and recycle this toolpath, and I decide that I want to use a different tolerance or a different thickness, let's change the thickness to 1 mm, and I recalculate the toolpath, then we get the all too familiar pop-up warning telling me that my boundary does not match my toolpath. Now this is important because the boundary is a shallow boundary, which is a tooltip boundary. And if I change my thickness, it now means the boundary is in the wrong position and I will not machine the correct amount of material. So now let's reproduce this toolpath using PowerMILL 2013 and the new boundary behavior in 2013, which is known as private boundaries. So we're going to start by creating a shallow boundary. And you can see a new entry at the bottom of the shallow boundary form, which is called private. Now this is where we allow the toolpath to be private or not private. By default, allow boundary to be private is switched on. Now what we mean by private is that the boundary will be the explicit property of the toolpath, and only that boundary will be associated with that toolpath, and that boundary can only be used by that toolpath. The boundary cannot be used by any other toolpath. So let's apply that boundary now to create the shallow boundary, which we can see on the screen. And now we'll create a new raster finishing toolpath. We'll just call it raster underscore PowerMILL 2013, and this time I select the boundary that I've just created. In this case it's called number 1. And if we calculate that boundary as before, then there is no difference at present to the behavior in 2012 R2. Let me just switch off the leads and links for a second. The big difference and the big benefit comes when we want to edit this toolpath or clone this toolpath. So if I go in and recycle this toolpath now and I change the thickness and calculate again, you'll notice that we do not get the error message now that the boundary does not match the tolerance or thickness of the toolpath. And the reason for that is that automatically in the background the boundary is being recalculated to match the toolpath parameters. So the boundary and the toolpath are always in sync. The parameters are always matched. Likewise, if I want to clone this toolpath, now because the new behavior only allows the boundary to be stored with one toolpath, it can't be used by multiple toolpaths. When we clone the toolpath, then a copy of the boundary is made. So here we can see we have 1_1. Okay. So with this copy I can then maybe choose a different tool. So make it an 8mm tool. So that will obviously, I've used a bigger tool, so that will obviously change the size and shape of the boundary. So if I now calculate again, you can see in the background it's recalculating the boundary automatically. So if I zoom in now and just cycle between, just to prove that, if I just cycle between the 8mm tool and the 6mm tool, then you can see a slight difference in the size of the toolpath between the 8 and the 6. Because the boundaries are private to the toolpath now, and they're directly linked and can only be used by that one toolpath, there's no need to show those boundaries in the Explorer tree. So you can see that the boundaries are not visible. Only the 2012 boundary that was created previously is visible. All the other boundaries that are private to each individual toolpath are not displayed. There is an option, if you want to see those boundaries, to switch on display private boundaries. And there we can see the two boundaries that are private, and to distinguish that they are private boundaries, they are shaded in the icon is a grey colour. This benefit goes much further. When we use component thickness sets in a toolpath, those will also be automatically inherited by the boundary as well, to make sure the boundary stays in sync. So if we go back to our last toolpath and recycle this toolpath and go to our component thickness. Now obviously with this shallow machining operation I wouldn't really want to machine this flat face around the outside. That would be done with a much bigger tool. So I'm going to select this face and set that face to be collision, so it's not actually machined. Likewise, I may want to leave some extra material on these faces here, on the tops of these bosses. So I'm just going to select those surfaces and put those on a different level and set those to have a thickness of 1mm. Okay, so we have put this surface on that collision level, which I forgot to do. Apply. So you'll notice that we still have a boundary segments for this flat region here. But if we recalculate this toolpath now, because the boundary is explicitly linked to the toolpath, then, and we've changed the toolpath thickness parameters, the component thickness, the boundary will automatically update its own component thickness parameters. So there we can see now that the toolpath has been recreated. It's not machined the flat area because we set that to collision, but also the boundary has been updated as well to remove the flat area from the boundary. And if we look from the side, you'll notice now we have the 1mm thickness on these surfaces, but the boundary has also been updated to match the 1mm thickness as well. If at any stage we don't want a boundary to be private, we want to use a boundary with multiple toolpaths, then when we create the boundary we just switch off the private boundary option. For example, maybe I want to create a boundary from the profile of the cavity. So that way, for that method I would maybe use a model boundary. So if I create boundary user defined from model, but this time I switch off allow boundary to be private and apply that. Delete that outer segment to leave the profile of the cavity. That boundary now can be used by multiple toolpaths. So I could go in now and do a constant Z finishing toolpath. Inside boundary number 2 and calculate. Now because that boundary is not private, you can see it's visible in the tree. And I can then go in and maybe use a 3D offset finishing inside that boundary, or sorry, not 3D offset finishing, but maybe a steep and shallow finishing. And I'm still using the same boundary. The private boundary behavior can be switched off by default for those users who prefer the old 2012 R2 method. So if we go to Tools, Options, Boundaries, we can switch off the Allow New Boundaries to be Private option by default. But obviously there are huge benefits in using private boundaries, with the main benefit being that the boundaries are automatically kept in synchronization with the toolpath. Any changes in the toolpath, such as thickness, tolerance, tool shape, component machining sets, they're all reflected in the boundary. All boundaries automatically updated at the same time.